everyone. I was just practicing my songs. I've improved since last week, haven't I? All right. I hope you had a great weekend. It was a wonderful weekend. Yesterday was a little chilly, but Saturday and Sunday were great, and Friday too, so I hope you got outside and were able to do something fun. And more importantly, do something good for somebody. Alrighty. Let's continue. We had a short exit ticket on Thursday, which most of you did pretty well, so good. If you didn't do so well, we're still going to be reviewing those same concepts and adding a little bit more. So let's get to it. Lesson 7. If you're printing out the notes or you have the notes on one side and me on the other side going over it, that's great. If not, grab a piece of paper and take some notes. Just so you know, if you do ask me, there you go. If you do ask me to explain something to you, I probably will say take a screenshot or take a picture of the work and send it to me, because that's the best way I can find out how you're doing and what you're doing. Okay? All right, so always make sure you're taking notes on paper and keeping that paper. Didn't mean to add that little ditty for you. Hold on to those papers until May 27th, May 28th, we should say. May 28th, you can do whatever you want with them, but please hold on to those papers until then. Okay, so today we're going to talk about how do you know if the linear equation will have one solution, 0 solutions, or infinitely many solutions. So this is what we tried to figure out last week. We tried to figure out if there was a solution, and if so, what it was. Okay. Remember, no solution meant the left side and the right side don't equal each other. Okay. Really easy way to look at an equation and figure that out. So that's what we're going to find out today. But just like we would in school, if we were in the classroom, it says on your own right there. So I would always say, go for it, right? You guys have the capabilities, you have the abilities. So I'm going to see if I can get all 3 on here. Nope. So we'll just do 2. All right, so pause the video, just like I'm going to, and we're all going to complete 1 and 2 together. Okay, come back when you are done, not before. Pause. Pause. And we're back. All right, so go ahead and look at my answers and your answers. For the first one, there is one solution, and that you easily solve for 4x, and that is 4. And I did go and double check over here, and yay, I got it right. So you should have 4. So x equals 4. Okay. For the second one, if you get rid of the x's right away, both x's cancel out, so they're gone. So you have a -3 left on one side and 5 left on the other. They don't equal each other. That is a big no-no. So that answer would mean no solution. Okay, we do have to do one more. So go ahead and stop the video and try that one to see what you get. Okay, and then for that last one, you should cancel out the 7x's. And so you'll have -3 on the one side, -3 on the other side. And yeah, they're equal to each other, right? Because you're left with the constants that are equal to each other, you know that there's infinitely many solutions. In other words, there are multiple, infinitely many numbers that I can substitute in for x to make that equation true. You don't believe me? Try it. Okay? Any number you can think of, we can substitute in there for x, and that equation will work. Now, looking at number 2, there's no number you can put in for x here for this to be true. No number. That's why there's no solutions. And for number 1, there's only one number you can put in. You can substitute for x to make that true. Okay? So, again, our possibilities are always one solution, which is just like this, no solutions, and infinitely many solutions. So by looking at those equations, you can tell how many solutions it will have, be it one solution, no solutions, or infinitely many solutions. okay, just by looking at it. And that's what we want, that's our goal today. Okay, so here are these equations again that we're going to take a look at. Remember, this one right here had one solution. That was number 1. This one right here had no solutions. That was number 2. And then the last one was number 3. So what I want you to do is I want you to try to figure this out. I want you to look at each of those equations. And what do they have different about each other that could possibly lead you to know, to predict how many solutions it would have. So pause the video, problem solve just for a couple minutes, and then come on back. All right, so what we want to do is compare those constants, which are those numbers without the variable. So the -3, -3, and the 5. Those are our constants in the first one. And we want to compare the coefficients, which are the numbers before a variable, before the x. All right, see if we can come up with some kind of conclusion. So here are the rules. You have to write these down somewhere, please. Okay, these are going to set you free. You will, life will be so much easier if you just have these rules to refer to. Okay, so write these down, print these out, take a snapshot, whatever you need to do. First thing you need to do is combine like terms. Okay, so combine like terms just the way we have been doing so far. We're going to combine like terms. Once they're combined, rule number 1, if the coefficients and the constants on both sides are different, then there will be one solution. So if they're both different, there's going to be one solution. Okay, so if you look at the first one, first example here, our constants are different as well as our coefficients. Okay, and there was one solution. Okay, we found it. X equals 4, I believe. If coefficients on both sides are different, both constants are the same, the solution is 0. Not no solutions. Number 2, I threw in there. It's not part of the lesson, but will be very helpful for you to know. If the coefficients on both sides are different, but the constants are the same, what would happen would be you would wind up with something like 7x equals 5x. Well, what can you put in there for x to make that true? 0. Okay, so 2 is not necessary for you to memorize, but it just is helpful. Number 3, you definitely have to know. If the coefficients and constants on both sides are the same, then you have infinitely many solutions. So if you look at this one right here, coefficients are both 7, and the constants are both -3. Even though they look, these two sides look different, they're the same thing, right? If we would turn this into addition, they'd be the same thing. Coefficients are the same, constants are the same. Therefore, there will be infinitely many numbers you can put in for x to make that true. And the last one, if the coefficients on both sides are the same, excuse me, if the constants are different, what is going to happen is these coefficients will go ahead and cancel out. Then you'll end up with one number equaling another number that's not equal. Okay, so it does not equal each other, so you would have no solutions. Let me say that. I'll just read the rule, see if that helps you. If coefficients on both sides are the same and the constants are different, then you will have no solutions. Okay, so our goal here for this whole unit is to be able to look at that simplified equation when the terms are all combined to see how many solutions it will have. If we know it has one solution, we will then solve for x. All right, so that's how that rock and rolls. So let's try some more. Okay, more practice on our own. Let's give a brief explanation as to what kind of solutions you expect the following linear equations to have. Transform the equation into simpler form if necessary. All right, so again, first thing you need to do is combine like terms. All right, once you combine like terms, you're going to look at the coefficients and the constants and see or make a prediction on how many solutions that will have. So go ahead and try number 4. And number 5, come on back and we'll talk about it. All right, so again, we're going to combine like terms. So that 9x plus a negative 2x or minus 2x is going to give you 9x. 11x minus 2x is give you 9x. I don't know if that's what I said. Anyway, and then over here, 8 plus 7 is 15. All right, so our simplified then equation would be 9x plus 15 equals 15 plus 9x. You notice your coefficients are the same exact thing. 15 and 15 are the same. Those are your constants. Okay, those are the same. So it's the same on both sides. So I can put in any number in the whole wide world for x and it'll work. Okay, so it would have multiple or infinitely many solutions. Okay, so I can write the coefficients are the same, the constants are the same, so there's infinitely many solutions. The next one, all right, I went to distribute it, right? So I want to look at the simplified version of the equation. All right, and here I see that the coefficients are different, and I see that the constants are different. So according to my rules, that should be one solution. So I should be able to finish this one and find one number that x is equal to. Okay, so one solution. And most of the time you won't have to do that for this lesson. You'll just have to, you won't have to finish the problem and find how many, or what the exact solution is. All right, number 6. Go ahead, pause the video. Combine like terms and try to figure out how many solutions this has. If it does have one, you don't have to go ahead to figure out what it is. You can if you want, but you don't have to. So go ahead and pause the video and come on back. And we're back. All right. So once you simplify this, by that I mean combine all the like terms, you get negative 10 on both sides of the equation. So you have the coefficients as the same, all right? The constants, the 32, the plain old numbers, the constants, the 32 and the negative 20 are different. So if we go back to our rules, and it says if the coefficients are the same, but the constants are different, coefficients and the constant on both sides are the same, no. If the coefficients on both sides are the same, yes, and the constants are different, yes, there'll be no solution. And that, in fact, is true because when we do take away the negative 10x's, we see 32 equals negative 20, and that's not true at all. So the answer is no solution. So there's nothing I can think of. There's just no existing number for x that I can put in this equation in order to make that true. So it won't work. Number 7. Go ahead, distribute that 1/2. Look at the coefficients. See if you can just look at the coefficients once you do that and the constants and make a determination of how many solutions. All right, good luck. Hopefully that didn't take you too long. Just go ahead, like I said, and multiply that 1/2 by each of those terms inside the parentheses, and you'll come up with 4x plus 13 equals 13 plus 4x. Same thing on both sides, right? Coefficients, both of them are 4, and the constants are both 13. So according to our rules, that means there's infinitely many solutions. We can put in infinitely many numbers for x and make that statement true. Mathematical statement. Okay. All righty. Okay, just to recap, 2 equations that have no solutions. Well, if they had no solutions, you would have to make sure that the coefficients were the same on both sides and the constants were different. Okay, that would give you no solutions. How about one unique solution? What would give you one unique solution? Different on both sides, right? Different coefficients, different constants on both sides. Oh my God, if the constants are the same, they'll cancel each other out, but if the coefficients are different, your answer is still going to be one solution, but that solution will always be 0. All right, we'll have practice with that in later lessons. Okay, and infinitely many, same on both sides. So if you got your coefficient on both sides, and that's the same, and the constants must be the same on both sides, and then you know you have infinitely many answers to that problem. It's I wish we could do more because it is so much fun to be doing this. So hopefully you understood what I was saying. Make sure you answer all the questions in the Edpuzzle, and I'll see you tomorrow in your Google form. Have a great day. And always email me with questions, please. Oh, and one last thing I forgot. Happy Cinco de Mayo. That just came into my head that today was Cinco de Mayo for you, because it's May the 4th be with you for me today. See ya.